Since time immemorial, the moon has captivated humanity's imagination. Its silvery glow, waxing and waning in the night sky, has inspired countless myths, stories, and scientific inquiries. As our closest celestial neighbor, the moon has always beckoned us to unravel its mysteries and explore its hidden landscapes. For centuries, telescopes offered us glimpses into the moon's cratered surface, fueling our desire to reach out and touch this celestial body. But it wasn't until the dawn of the space age that this dream transformed into a tangible reality. The mid-20th century witnessed a fierce rivalry between the United States and the Soviet Union, extending beyond Earth's atmosphere into the uncharted territory of space. This competition, known as the space race, became the driving force behind humanity's first tentative steps toward the moon. The quest to conquer the unknown, coupled with the geopolitical climate of the Cold War, set the stage for an era of unprecedented technological advancements and daring missions that would forever alter our relationship with the moon. The Soviet Union took an early lead in the race to the moon. In 1959, Luna 1 became the first human-made object to escape Earth's gravity and fly past the moon. This groundbreaking achievement marked the beginning of a series of Soviet successes. Later that year, Luna 2 made history by becoming the first spacecraft to reach the lunar surface, albeit through a planned impact. This mission provided valuable data about the moon's environment and paved the way for future soft landings. In a stunning display of technological prowess, Luna 3 captured the first-ever images of the moon's far side, a region perpetually hidden from Earth's view. These grainy, yet historic images revealed a starkly different landscape from the familiar near side, further fueling our curiosity about this enigmatic celestial body. The Soviet Union continued its string of successes with Luna 9 and Luna 13 in 1966, achieving the first soft landings on the moon. These missions transmitted panoramic images of the lunar surface, providing humanity with its first glimpse of the moon's desolate beauty. The United States, initially trailing behind in the space race, responded with unwavering determination. NASA's Apollo program, a monumental undertaking of human ingenuity and technological innovation, aimed to land humans on the moon and return them safely to Earth. The Apollo missions were characterized by a series of incremental yet crucial steps. Apollo 8 in December 1968 became the first crewed mission to orbit the moon, capturing iconic images of Earthrise over the lunar horizon. This mission proved instrumental in testing the spacecraft and lunar orbit rendezvous techniques, paving the way for future landings. In May 1969, Apollo 10 served as a dress rehearsal for the moon landing. The mission successfully tested all aspects of the lunar module's descent and ascent, stopping just short of actually touching down on the surface. Finally, on July 20, 1969, the world watched in awe as Apollo 11 fulfilled President John F. Kennedy's ambitious goal of landing a man on the moon before the end of the decade. Neil Armstrong's historic words, "That's one small step for man, one giant leap for mankind," echoed across the globe, marking a pivotal moment in human history. Following Apollo 11's triumph, 5 more Apollo missions successfully landed on the moon, further expanding our understanding of this celestial body. Astronauts conducted scientific experiments, collected lunar samples, and explored the lunar surface using rovers. The Apollo program's impact extended far beyond the moon. It spurred countless technological advancements in fields such as materials science, computing, and communications, many of which have had profound implications for our daily lives. Moreover, the Apollo missions inspired generations of scientists, engineers, and dreamers, igniting a passion for space exploration that continues to this day. The program demonstrated the power of human ambition and international collaboration, proving that seemingly impossible goals could be achieved with unwavering dedication and a shared vision. The Apollo program came to an end in 1972 with Apollo 17, the last mission to land humans on the moon. In total, 24 astronauts had ventured to the moon, with 12 walking on its surface, leaving behind an enduring legacy of scientific discovery and human achievement. Section 5. A lull in activity, awaiting new dreams. After the Apollo program concluded, a sense of complacency settled in. The political climate had shifted. The space race had lost its intensity, and budgetary constraints led to a decline in lunar exploration. For several decades, the Moon, once a primary target of human ambition, seemed to fade into the background of space exploration priorities. This period marked a stark contrast to the previous era's fervor, as missions to other planets and the development of space stations took center stage. However, the allure of the Moon never truly faded. Scientists continued to analyze the wealth of data and lunar samples brought back by the Apollo missions, uncovering new insights into the Moon's formation, composition, and potential resources. Meanwhile, technological advancements continued to evolve, paving the way for more sophisticated and cost-effective missions. The stage was set for a resurgence in lunar exploration, driven by a new generation of scientists, engineers, and entrepreneurs eager to unlock the Moon's secrets and harness its potential for the benefit of humanity. Section 6. Renewed interest, rising to the challenge. The 21st century witnessed a renewed global interest in lunar exploration. Driven by scientific curiosity and economic potential, space agencies and private companies set their sights on the Moon once more. China emerged as a major player with its ambitious Chang'e program. The program achieved significant milestones, including the first soft landing on the Moon since 1976, with Chang'e 3 in 2013. Chang'e 4 made history in 2019 by landing on the far side of the Moon. This mission provided unprecedented insights into this unexplored region. India also joined the ranks of lunar explorers with its Chandrayaan missions. Chandrayaan-1, launched in 2008, discovered evidence of water molecules on the Moon's surface. Section 7. Artemis and Beyond. A sustainable future on the Moon. NASA's Artemis program, named after the Greek goddess of the Moon, represents the latest chapter in humanity's quest to explore the lunar surface. Launched in 2017, Artemis aims to establish a sustainable presence on the Moon, paving the way for future missions to Mars. The program's goals include landing the first woman and the first person of color on the Moon by 2025, developing technologies for lunar surface operations, and fostering international and commercial partnerships. Artemis envisions the construction of a lunar gateway, a space station in lunar orbit. This gateway will facilitate exploration, enable scientific research, and act as a stepping stone for human missions to Mars. This global resurgence in lunar exploration highlights the Moon's growing importance for scientific discovery and technological innovation. Section 8. Conclusion. The Moon Beckons. As we stand at the cusp of a new era in lunar exploration, the Moon once again beckons us with the promise of untold discoveries and the challenge of pushing the boundaries of human ingenuity. The lessons learned from past missions, coupled with advancements in technology and a renewed spirit of international collaboration, have paved the way for a future where humanity's presence on the Moon is not a fleeting visit, but a sustained endeavor. The Moon, once a symbol of distant wonder, is now within our grasp, a stepping stone to the vast expanse of our solar system and beyond. As we venture further into the cosmos, the Moon will serve as a testament to humanity's enduring spirit of exploration, a beacon of inspiration for generations to come.